Good morning, students. As we all know, acid, base, and salt is a very important chapter, and here we'll discuss today about the salts. Okay, three topics are there: acid, base, and salts. Three different topics are there, but today we'll start with salts. Salts are very important part of our life. So let us begin with. Let's go for it. Salts. Okay. We all know the salt which are using in our kitchen, that is NaCl. That is called NaCl. Its name is common salt. Okay. Its name is common salt. Why we say it's common? Because because it is not a acidic or no basic. It's a neutral salt. Okay. So it is called common salt, and we all know how during freedom movement how Gandhiji's help struggle to make salt from the sea water. See, so that is what an important part of our life, but it also helps as an in making important chemicals. It is used as a important raw material. Okay, so for making different chemicals. Okay, like bleaching powder, CaOCl2, washing soda, baking soda, and many more chemicals are there. Okay, so we will discuss one by one how this salt is used in making all these chemicals stepwise. So first one I am talking about is NaOH, sodium hydroxide. Okay, how it is formed? We can say when and electricity is passed to an aqueous solution of of sodium chloride, what will happen? It decomposes to give NaOH. It decomposes to give NaOH. It's a plus. More important products will find Cl2 plus hydrogen gas. These two important products. So when an electricity is passed through an aqueous solution of sodium chloride, it decomposes to give NaOH. That is called brine. That is called brine solution. Okay, that is brine. And here we found two more important products. First of all, let us balance it, because Cl2 is 2, as we all know. Balancing is more important as writing a chemical reaction or chemical equation. So here I will try to balance this. Okay, chlorine are 2 atoms here also, plus 2 atoms of sodium and 2 atoms of sodium. Okay, plus if I talk about this also, find this. Okay, because we all know here what I got this. Okay, so 2 plus 2, 4 hydrogen, plus we have 2 oxygen. Now it is completely balanced. Okay, so this process is called chlor-alkali process. I will tell you how. Because chlor-alkali, because here chlorine is produced and alkali is produced. Alkali means water soluble base. All bases are not water soluble. So those bases which are water soluble, they are called alkali. So that is why this process is called chlor-alkali process. Okay, chlor-alkali process. Okay, let me show you how through a small diagram. Okay, if I try to make two cathodes, sorry, two electrodes, if I say two electrodes, then connect with them with a battery. Here plus one and here is a negative one. Okay, so this is cathode and this is anode. Okay, this is cathode and this is anode. Now how, let us see how this can be made prime. Okay? Now I hope so. It's clear to you. Okay. This is what is we have memory. Okay. Now what happens is, let me show you. So you will be able to easily identify that is easily identify that chlorine gas is given off at cathode and hydrogen gas is given off at anode. Okay, we all know cathode is our, I think we have written a wrong thing. Here it is, will be cathode here, okay, and here it is will be anode. Okay, anode is positive and cathode is negative. These two electrodes I am using. If I say here Cl negative and OH negative ions, and here if I transfer H plus and Na plus, and here is what I will show you how brine containing NaOH. Brine, this solution is called brine when electricity is passed to an aqueous solution of sodium chloride. It decomposes to give NaOH. That is called brine, and that is called a chlor-alkali process because here chlorine is produced. Okay, and NaOH is an alkali. We all know base. Not all bases are water soluble. So some bases are water soluble, and that is therefore called alkali. That is why this process is called chlor-alkali process. Okay, we all know hydrogen is used as a fuel, rocket fuel, as for ammonia, I can say, for fertilizers, for making ammonia for fertilizers are there. Okay, and here chlorine. What is this of chlorine? For water treatment. We all know chlorine gas is used for water treatment is used. Okay, plus we can say for the disinfectant. Disinfectant we have PVC. Okay, so a lot of things where chlorine gas is used, plus also for swimming pool. We all know in swimming pool chlorine gas is used, okay, to disinfect for clean water. Okay, so this is the chlor-alkali process. Chlor-alkali process. Okay, most important chemical now we found NaOH. Okay, so NaCl is an important raw material for making NaOH. Now, why we make NaOH? Because NaOH is used in many fields, like in the paper industry it is used. Okay, paper industry is used in lot more things we use NaOH. Okay, so that is why we say that it is an important chemical. Okay, so important chemical which is made with the help of NaCl as a raw material. So this is the chlor-alkali process. Okay, this is anode positive and this is cathode, that is negative, and so this is how these ions are passed. Okay, and NaOH formed is near the at the bottom of the cathode, that is containing, that is brine, that is containing NaOH. Okay, so this is an important chemical. Now we'll move to the next one, that is called the second one. Okay, I hope so it is clear. I will take step by step and will try to explain all chemicals in brief and in detail also, so that you are able to connect with me. Okay, so now let us move to the next chemical, that is called bleaching powder. Okay, so now I hope it is clear to you how NaOH is more important. Okay, as it is used In paper industries, artificial fibers, soap, in making soap, detergent, lot more in the different fields and which is used. Okay, so now that is an important chemical. Now next one I'm talking about bleaching powder. Next one is bleaching powder. It is also an important component, a chemical we can say. Okay, bleaching powder. Okay, how it is formed? We all know how Cl2 gas formed in is produced, when electrolysis is done of NaCl in. Okay, so we got the decomposes to give NH plus chlorine. So here chlorine gas is used to, the action of dry slaked lime. Okay, here I am using this dry slaked lime, dry slaked lime plus I am using chlorine gas. What it will give? It will form bleaching powder. That is called, what that is, formula is CaOCl2 plus water. Okay. So Cl2 is used on the action of dry slaked lime. So we got the CaOCl2, that is called bleaching powder. Its another name is calcium oxychloride. Its another name is calcium oxychloride. So why we form this? What are its uses? Most important uses I will tell you now. First of all, it is used as an oxidizing agent. It is used as an oxidizing agent in many chemical industries. Another one, for making drinking water, free from germs. As we all know, it has chlorine. We all know that it has chlorine. Okay. And the third one is it is used to bleach, cotton and cotton. I will write full so that you are able to understand. It is used for to bleach cotton and linen in textile industry. Also, it is used to bleach. Wood pulp in paper factories. Paper. I'll write full. So I can say that it is used to bleach cotton and linen in textile industry. Also, it is used to bleach wood pulp in paper factories. We all know how wood pulp is more important in making paper. Okay, so that is why this chemical is produced. So we can see from the top, that is NaCl is an important raw material for making different chemicals. So why we make these chemicals? Because they have different uses. That is how we make chemicals. Okay, so chemicals are made. Okay, so first one is a NaOH. Okay, second one is a bleaching powder. Now we'll talk about third one, and the third one is baking soda, NaHCO3. We'll talk about now what is NaHCO3, why we call it baking soda, it's another name, and let's see. Okay, so yes. Now we have studied the two salts that is NaOH and bleaching powder. Now we'll talk about third one, that is baking soda. Okay, let us see how and you know. So we able to understand now that how NaCl is more important as raw material is used in preparing such kind of salts. Okay. So now let us move to this third one, that is called NaHCO3. Okay. NaHCO3, that is baking soda. That is called baking soda, and its formula, if I say chemical compound name, is sodium hydrogen carbonate. Okay, NaHCO3. Okay, so now we all know baking soda is used in our kitchen, to make crispy pakoras, and sometimes it is also used in, for faster cooking. So let us see how this salt is produced by using NaCl plus water plus CO2 plus ammonia. So that I got here ammonium chloride plus NaHCO3. Okay, that is called baking soda. That is ammonium chloride plus, this is called, what is this called? Baking soda. Okay, it's called baking soda. Okay. We all know after writing the equation we need to balance it. Okay, so we can see here sodium atom single on both sides, on the reactants and the product sides, and here if I use this CO2, C single atom is now we have oxygen, we have 3, it's completely balanced. Okay, now what hydrogen, if I talk about, we have 5 atoms, so it is completely balanced. Okay, now let us talk more about baking soda. Sometimes in board exam teacher asked what is the nature of NaHCO3. Basically it is a non-corrosive basic salt which is used as an to neutralize an acid. Okay, so that is what is all about NaHCO3. If I go for uses, first one is it is used in soda acid fire extinguishers. Okay, extinguisher. We all know extinguishers are a lot more about. We will lot of types of extinguishers we have. Now it is used in soda acid extinguisher. Second one, it is used as an antacid. Second one, it is used as an antacid because it neutralizes HCl in our stock. Okay. One more use, if I say that it is used to prepare baking powder. Okay, it is used to prepare baking powder. Okay, sometimes it is baking powder is how you form the baking powder. If I if I use NaHCO3 plus H plus any acid I am using here. If I say any acid, I can take an example of tartaric acid. That is mild edible acid is used to form what? We form CO2 plus water plus sodium salt of acid. Okay, so that is how we make the baking powder. Baking powder is a combination of both sodium hydrogen carbonate plus mild edible acid, that is tartaric acid. Okay, So this is about NaHCO3. Okay. So now here CO2 is formed. CO2 is used, to make to cake or pastries rise, so that they makes soft and spongy. Okay. So to make cakes soft and spongy, you use CO2. Okay. To in cake or dough, they try to make it rise. Okay. So that is what is given about the baking soda, and let us study more about that is NaHCO3. When you try to heat it, it's a symbol of heat. What will happen? What you will got? Na2CO3. Okay. When you heat it, you will got Na2CO3. Okay. That is called washing soda. That is called washing soda plus water is used. Okay. When you heat this, you got, when you heat baking soda, you got washing soda. That is called sodium carbonate. Its chemical compound name is sodium carbonate. So that is how this is formed. Okay. So this is a third important salt which is made with the help of NaCl. So we able to know now, see how NaCl is an important raw material for making these important salts. Now let us move to the next salt, that is washing soda. That is washing soda. Okay. See, now we are able to know the three salts. Now we'll move to the fourth one. The fourth one is washing soda. So I will write here Na2CO3. Okay. That is called washing soda. Okay. What I have got after heating this, after heating baking soda, I got dry sodium carbonate. So here what I will do is, I will add water crystals. I will add at least 10 molecules of water, so that I got the Na2CO3 dot 10 that is called washing soda, or that is Na2CO3 sodium carbonate having 10 crystals, 10 molecules of water crystal. Now here one question arises from the crystal, that is called recrystallization. Recrystallization means adding water molecules to the compound so that it becomes having water molecules. Depending upon how much we add, so that is what I got here. That is called washing soda. That is called washing soda. So this is called washing soda. Now, washing soda have many uses. Washing soda and baking soda, both are important chemicals and used in various industries. Now, what are the uses of washing soda? It is used as a cleansing agent. Cleansing agent in many domestic purposes. Number 2, used to make sodium compounds. Sodium compounds such as borax. Such as borax. You will study this in higher classes. So it is used to make sodium compounds such as borax, used to as a cleansing agent in domestic purposes. Okay. Domestic purposes. It is used to make. It is used to make soap. Okay, it is used to make soap, glass, and it used in paper industries. Paper industries. So this is what It is used as a cleansing agent in domestic purposes. It is used to make sodium compounds such as borax. It is used to make soap, glass, and it is used in paper industries. Okay, so this is used in many industries. So that is why we now able to know that how these salts or chemicals are more and more important. Okay, now let us talk about next one, that is gypsum. Okay, so this is we have discussed now till now we have four chemicals. Now we will study about fifth chemical. Okay, so let us see what is given. Now I hope we are able to explain all these four chemicals. Okay, as we know now, these two, baking soda and washing soda, are two important chemicals and they are used in different fields. Now let us move to the next one, that is POP, plaster of Paris. Okay, that is called POP and plaster of Paris. Now POP, fifth one, that is called plaster of Paris. Plaster of Paris. Its formula is CaSO4 dot half H2. Okay, CaSO4 dot half H2. CaSO4 dot half H2. Now how it is formed? So it's POP. I can write here how it is formed when it loses water. And gypsum is a hard mass. Now let us see how it is formed. Now here I will write CaSO4 dot 2H2. This is a gypsum. Okay, this is a POP, plaster of Paris. Basically it is a white powder and containing half molecules of water, and when adding further water to it, it becomes gypsum when it is mixed in water. Okay, so that is called CaSO4.2H2. Gypsum is used. So gypsum is very hard. Okay, now POP, you know, it is used to make toys, for decoration materials. It is used here, and gypsum is a hard mass. You know, it is used for where? It is used for its another name is calcium sulfate hemihydrate. If I write here, that is calcium sulfate hemihydrate. It's another name. Hemi I have hemihydrate. Okay. So this is name. When gypsum loses water, it becomes POP, CaSO4 half H2. We all know gypsum where it is used. It is used by doctors, you know, in making right bones, fracture bones, to make it make it in right position. Okay, and lot of things, other things also made by this gypsum. So it's a hard mass, and when it loses water molecule, it becomes POP, plaster of Paris. That is called calcium sulfate hemihydrate, and this is formed when it is mixed in a, you know, it's a white powder. When it is mixed in water, it gives hard mass gypsum. Okay, so this is the POP, that's called plaster of Paris. So today we able to learn about these five chemicals and how NaCl plays an important role, that is common salt, as a raw material to manufacture, to make these, help in these chemicals. Okay, so this is about the salt topic, that is from the, I've taken it from the acid, base and salt. Instead of explaining or, you know, learning full chapter, I've just explained the salts. So that is for today. Thank you.